All right, so we're going to take a look at page 66B in preparation for our 9C quiz. Take note that the directions for all of these say to factor completely, or at least 1 through 6. So you're going to have to apply which strategies we've learned for each polynomial to figure out how to properly factor it. Note if there's a problem in here that you already know how to do, you can skip ahead to the other problems. I think in the description, I'm going to have locations for each of the start of the different problems being done. So for number 1, first, for every polynomial, let's take out a GCF. Okay, and actually you can take out higher than a 2. We can take out a 4. Okay, what's left here? We have a difference of squares. Seeing as it's a binomial, difference, 2 perfect squares. So we're going to end up with 1 that's addition, 1 that's subtraction. It's k plus 5, k minus 5. Okay, that's it. All right, here's our next one, number 2. Again, look to take out a GCF. In this case, take out a 3. K squared minus 6. All right, we want to take a look right here. See, is it a difference of squares? If it's 2 of our criteria, difference, and it is a binomial, but although this is a perfect square, this is not. 6 is not. So this is our final factored form. Okay, 3 and k squared minus 6. Okay, this next one. This is a type 2 trinomial. Type 2 trinomial. First thing you should do, look to factor out a GCF, as always. In this case, we could take out a 2, and we're left with 9x squared minus 3x minus 20. Okay, I'm going to bring this 2 down to where our answer is. That way we don't have to bring it with us each of the steps where it gets a little crowded. So we can just bring it there for later. So here we have a type 2 trinomial that we have left. You could check to see if it's a perfect square trinomial. This would be 3x. This isn't a perfect square. But from there, you'll have to factor this like a normal type 2. So in this case, a times c is negative 180. So we want to multiply that and add to negative 3. So let's do prime factorization. We have 18 and 10. We have 9 times 2, which is 3 times 3 times 2. And we have 5 times 2. Okay. So if we mix these up and we try them out, it ends up being, let's say, 3 times 3. I think 3 times 5, which is 15. And we have 3 times 2, which is 6 times 2, which is 12. Okay, so there's our magic numbers. We need the bigger one to be negative. So I'm going to go ahead and erase that. Our magic numbers are negative 15 and 12. So negative 15x, 12x. Okay, we could do our grouping. Here we could take out a 3x, and we're left with 3x minus 5. Here we could take out a positive 4, and be left with 3x minus 5. Okay, so our final factors then are 2, 3x minus 5, and 3x plus 4. Okay, whoops, plus 4. Okay, for this one, we have 4 different terms, so we know we're going to have to factor this by grouping. From the beginning, look to see if you can take out a GCF. In this case, you can take out a 2, okay? That would be what I recommend. Take out your 2 and then factor the rest by grouping. On our previous quiz, the 9B, most people forgot to do that. So I'm going to show you what you can do if you forgot to take out the GCF and how you would do it then, okay? But if you realize there's a 2, take the 2 out, use it in your final factored form. So here we go. I'm going to go ahead and factor this by grouping. Make sure to get that negative sign in with this one. So we have 2m squared, and you're left with 2m plus 3. Here you take out a negative 8, and you're left with 2m plus 3. So some of you might leave it right here and say, okay, we're done with our 2 factors. However, right here you see, there's a GCF still. Okay, so you take that out. 2m squared minus 4, 2m plus 3. Once again, don't stop. Make sure you look at each binomial. Make sure there is not still a difference of squares. In this case, there is. So this would split up to m minus 2 and m plus 2, while also bringing down our other previous factors. Okay, so here is our final factored form for number 4. All right, for this one, we want to first look to see if there's a GCF. There is not. This is a trinomial, it's a type 2. But I noticed that this right here is a perfect square, and so is that. So I'm thinking this might be a perfect square trinomial. So let's go ahead and write down, this is square root of that would be 4x, square root of this would be 1. And we're looking for this to be 2 times a times b. So a times b is 4x, times 2 is 8x. Okay, so it is a perfect square trinomial. So our answer, we could just jump to, is a 4x, 1. This plus sign comes down, and it's squared. This is the answer for number 5. All right, so this one right off the bat, I can see that it is a difference of squares. It will split up to 4x squared minus 9 and 4x squared plus 9. Okay. We keep looking. Make sure you always look at the ones that are different to make sure that they aren't different squares. In this case, it is. So we can split it up again. 2x plus 3, 2x minus 3, 4x squared plus 9. This can't be split up because it is a sum. So this would be our final factored form. All right, so our directions for 7 and 8 are no longer to factor completely, but it is to solve. So we're going to have actual numerical solutions for x. So we're going to move over this 22x. Make sure you always keep the leading coefficient positive. So yes, we can move these both over there to set it equal to 0, but you should keep this positive. So minus 13x squared, add this over, equals 0. Okay, so we're now going to go ahead and factor this type. Actually, I take that back. Sorry, we're going to factor out a GCF. So in this case, it would be x. We're left with x squared minus 13x plus 22. All right, now we're going to go ahead and factor what's left in here as a type 1 trinomial. So we're looking for things that multiply to 22, but add to negative 13. So I know right off the bat that would be 11 and 2. Both have to be negative. So we could just jump right to our binomials. X minus 11, since it's a type 1. X minus 2 equals 0. And here it's now time for t. Okay, use the zero product property. So in here, x would equal 0. X equals 11, and x equals 2. These would be our 3 solutions. All right, we have another problem where we have to find the solution. So we should set it equal to 0 by moving our 3x over. Remember to keep it in descending order, so this is actually going to end up in the middle. I see there's a GCF we could take out of here, which is a 3. We're left with 10x squared minus x minus 21 equals 0. I looked to see if this is a perfect square trinomial. In this case, it's not because these are not perfect squares. So we're just going to have to factor this like a normal type 2. So we're looking to multiply to negative 210, but add to negative 1. So let's do prime factorization. 21 and 10, 7 times 3 times 5 times 2. Okay, so in this case, these 21 and 10 is 11 apart, so we need our factors to be closer. So maybe switching around 7 and 2, so that'd be 14, 3 and 5 is 15. All right, cool. So we need it to be negative, so the bigger one is negative. All right, here we go. So I'm going to bring our 3, you can either bring your 3 down or you can actually divide it out right away, because if you divide both sides by 3, it goes away. But it ended up giving us a nonsense answer anyway at the end. So let's go ahead and work with it. Here's our magic numbers. We'll group. Here we could take out a 5x, left with 2x minus 3. Here you could take out a 7, left with 2x minus 3. So this is the point where you, if you chose to keep your GCF of 3 in here, you ended up using the zero product property and sees 3 doesn't equal 0, and it cancels out. But here we're going to use the zero product property, and we're going to see that x here equals negative 7/5, and here x equals 3/2. Okay, here are our 2 solutions for x. All right, in this problem, we're looking for the value of k so that this would be a perfect square trinomial. So we're looking for the square root of this would be 4x. Square root of this would be 3. Okay, we know that k has to be 2 times a times b. Okay, so if it's a times b is 12x, times 2 would be 24x. But we don't need the x because it's already here. So this value for k can either be 24, but it could also be a negative 24. Remember that the form it's going to end up factoring to would either be this or this. Okay, so this right here could be either positive or negative. So here's our answer, plus or minus 24. Okay, for this one, I did not show you how to do this one yet, so you're not going to need to know it for your quiz, but for those who would like to see it, here it is. So what we know is this middle term, so in this case, k is missing from our last term. Okay, so we know that this middle term has to be equal to, technically it's plus or minus 2 times the square root of this term times the square root of this term, which is just k for right now. Because this is negative, actually, we know that it must be negative, not positive. So let's go ahead and, now we're just kind of solving an equation. So we have negative 30 is equal to negative 2 times 3, because the square root of 9 is 3. Okay, this is a negative 6. Okay, let's isolate this right here, the square root of k. So we're going to divide both sides by negative 6. So positive 5 is equal to the square root of k. Okay, the way that you cancel out a square root is by squaring both sides. Okay, that is the reverse of taking the square root, is squaring it. So what that's going to leave you with is just simply k. So k in this case equals 25. Okay, we'll talk more about this one in the future, but just for those who wanted to see it, k does equal 25.